In example 5, we have a sociology application of the binomial probability. So increasingly, children in our society are being raised by their grandparents. So according to a random sample, 25% of grandparents were raising their grandchildren. We take 20 randomly chosen grandparents, and we want to know what is the probability that exactly 8 are raising their grandchildren. So this is binomial probability. You pick a random set of grandparents that either are or are not raising their grandchildren. So there's only 2 outcomes. P is 0.25. So a success is going to be that that set of grandparents is raising their grandkids. And the probability of success is 0.25. So N is 20 because it took 20 randomly chosen grandparents here. And then in part A, we want to know what's the probability that exactly 8 are raising their grandchildren. So this is going to be probability x equals 8. We're going to use Binomial Pdf for that. So we'll go to the calculator, second variables, and scroll down to Binomial Pdf, which is option A. Enter. Our trials are 20 sets of grandparents, RP 0.25, and then x is equal to 8. So 060880609. So about a 6% chance that exactly 8 would be raising their grandkids. What is the probability that more than 1 are raising their grandchildren? So this is asking what is the probability that x is greater than 1? Well, remember that binomial CDF can only do less than or equal probabilities. So we have to rewrite this using the complement event or the opposite event. So 1 minus the probability of the opposite, which is x less than equal 1. Because greater than 1 would be 2, 3, 4, 5 up to 20. So the opposite is less than equal 1. So we can do this on the calculator. So we want 1 minus second variables. I want to go to CDF. Option B. Our trials are 20. P is 0.25. And we want x less than equal 1. So we got a 1 there. We will paste that and then calculate. So notice that I did 1 minus that binomial CDF. So 0.9757. So almost a 98% chance that more than 1 set of grandparents out of that sample would be raising their grandchildren. What is the probability that between 1 and 5? So if you're strictly between 1 and 5, that would be probability that 1 is less than x. Oops, we want less than, strictly less than. X is less than 5. So if you're strictly between 1 and 5, that would be 2, 3, or 4. So remember, we have to rewrite this with less than equal probabilities. So let's do less than equal 4. So probability that x is less than equal 4. So that's going to be x is 0, 1, 2, 3, or 4. And then we want to take off 0 and 1, and we'll be left with 2, 3, 4. So minus probability that x is less than equal to 1. So that's x is 0 or 1. So we take those out, we're left with 2, 3, 4. So we need binomial CDF for each one of those. So now we're going to the calculator. So we want second variables. Come down to CDF. Trials and P are already in there. We are starting with less than equal 4. So I need a 4 for x. We will paste that. Minus. And then second variables again. Come down to CDF, which is option B. And we just need to change our x value. N and P are still the same. We're doing less than equal 1, subtracting that off. So I need to change that 4 to a 1. Enter, paste. And we've got our subtraction there. Enter computes it, 0.39052, 3905. Now, if it helps you keep track, you can write out the binomial CDF command, but that's not necessary. Find the mean and the standard deviation of the distribution. So this is a binomial distribution. So for binomial distribution, your mean is mu equals n times p, and Rn is 20. Wrote 2, should have written 20. P is 0.25, so 20 times 0.25, which is 5. So our mean is 5. Standard deviation, a shortcut formula, NP 1 minus P. So that's going to be square root. N is 20, P is 0.25, and then times 1 minus 0.25, which would be 0.75. So let's compute there. So we want a square root of 20 times 0.25 times 0.75. 1.94 to 2 decimal places. So we've got our mean. So that means that out of those 20 sets of grandparents, on average, we'd expect to see 5 sets. We're raising their grandchildren. And then remember, standard deviation is the measure of the variability. And then lastly, they want us to sketch the histogram for the distribution and ask what shape is it. So to sketch a histogram here, we can just use Binomial Pdf, but put in N and P, but don't put in an X value. So I'll list your whole distribution. So if we go to the calculator here, you can go to second variables, come down to Binomial Pdf, which is option A, and our trials are 20, and our success 0.25, and then leave your X value blank. Come down and paste it, and enter. So our probability of 0 is 0.00317, so 0.0032. Probability of 1, 0.0211, and etc. So you keep going to the right. Probability of 2, 0.669. Probability of 3, 0.13389, so it's 0.1339, etc. And just arrow to the right, and you've got all those probabilities that are listed for you. So if we draw that histogram, it'll look like this. So this is our X value, and then on the vertical here is relative frequency. Relative frequency, because the output is going to be in percents. So this is going to be relative frequency. And to identify the shape of this distribution, we want to look at what smooth curve here would go through the centers of the bars. So something like this. And we can see that that is not quite bell-shaped, but it's pretty close. So this is a fairly symmetric or bell-shaped curve. Or you could say mound-shaped, mound or bell-shaped. It's only slightly skewed to the right. You see the tail goes off a little farther to the right than it does to the left. But this one is pretty symmetric. And what happens here is your probability, the 0.25, the closer that is to 0.5, and then the bigger your value of n, the closer this thing's going to be a bell-shaped curve. So in that case, we can sometimes approximate our binomial distribution by using the bell-shaped curve.